Try to read the text shown on your screen. Are you able to read it? Well, not unless you have the eye of an eagle. The text here is too small to be read. What if I bring a magnifying glass over it? Are you able to read it now? Yes, now the text appears bigger. So what's so special about a magnifying glass? This glass has a lens in it. This lens is responsible for making the text appear bigger. Where else do you think this lens can be used? Yes, you are correct. This lens is used to view tinier objects. So as you must have guessed, it's used in telescopes and microscopes. In a telescope, the lens produces an enlarged image of the celestial bodies. Whereas in a microscope, it's used to look at tiny microorganisms. Now the obvious question that must be buzzing in your mind is, what is a lens? First thing about a lens that you can immediately tell is that it's transparent. It is evident from these examples. We are able to see the text through the lens. However, the window glass is also transparent, but we are unable to see small or faraway things through the window glass. Why is that? This is because a window glass does not magnify the objects. So the difference between the two is that this lens magnifies the object, whereas the window glass does not. But will the image formed by a lens always be magnified? Not really. This depends on the distance between the object and the lens. Yes, there is only a specific range of distance at which the lens should be kept in order to get a magnified image. All of this comes under the image properties of a lens. And we will learn these properties in our next video. Here we will look at the types of lenses. Yes, lenses also come in different types. They are basically divided into two types: simple lenses and compound lenses. A compound lens is a combination of two or more simple lenses. However, we will look only at simple lenses. And among them, we will only be looking at convex and a concave lens. The lens that we saw in magnifying glass was a convex lens. If you move your hand over a convex lens, you will find that it's thicker in the middle region and thinner at its edges. What about a concave lens? If we move our hand over the concave lens, we will find it to be thicker at the edges and thinner in the middle. Both the lenses are transparent and they both form images of objects. Just like in the case of spherical mirrors, here too the properties of images vary with the object's distance from the lens. We will study these properties in our next video.